Welcome everybody. Thank you for joining us today for another CTC software webinar. Today we're going to continue in our site design series with part 4, generating volumes. In the past series we did some existing conditions and some rough grading. Today we're going to get those volumes. So my name is Tony Crick. I'm the Civil Product Manager here at CTC Software. If you're watching this on YouTube and you have questions, you can go ahead and put them in at the bottom and we will see those. And if you want to get any of our future webinars, you can go to our website, ctcsoftware.com, and pre-register so you don't miss another one. So with that, let's get started. So this series is a series of webinars that shows how CTC Software CIM Project Suite of tools can help save time and help you get things done more quickly in a site design situation. So it's going to focus on our project suite and Earthwork Processor, which is one of the CIM suite of tools. It's intended for the everyday Civil 3D user creating design and production drawings. It will work currently in the last 4 versions back to version 2020, but when Civil 3D releases version 2025, we will no longer be supporting version 2020. So what are our CIM project suite of tools? We have a whole suite of tools that are meant for the everyday design production of a design set. And they're set up to help automate time-consuming tasks. We have tools for survey, piping, grading, which we're going to be focusing on today as Earthwork Processor. We have corridor tools, and we have our general tools with Label Genie, which you can label just about anything in your drawing with, and Clash Seeker, our newest CIM project tool. And we have a Data Wizard to help us with legends, quantity takeoffs, and other things. And then Sheet Generator, which helps us expedite the production of our final plan sheet. And all of our tools are built into Civil 3D for consistency and familiarity. We have no proprietary files, so they're readily shared across the platform. So why Civil Project Suite of Tools? Like I mentioned before, they will help you save time during the design and production process. We can save templates for most of our tools to maintain consistency and to avoid surprises, and also to expedite things. And with that, new team members can pretty much plug and go. And we have an easy interface that mimics Civil 3D, which will flatten the learning curve for those new members. So we can jump into our live demo, part 4 here, as I mentioned before. The previous part 1 was existing conditions and platting for quantities and removals. Part 2 was a grading of phase 1. Part 3, we refined our grading and did some more surface grading with lots. And today we're going to show you how to generate volumes from those. So with that, let's jump into it and get started. So here's our background, our basic set that we started with. I'll turn on the background here. It's a vacant site, former agricultural site, and we're going to be developing this whole site, approximately 80 acres. Today we're working on and have been focusing on this area here, phase 1 of this project. So maybe we'll get that background off of there. And in the previous webinars, we first started out with these roads, and we graded these roads using auto grader to create the surface that we will build off of. In part 2 or 3, we did this lot grading up here. So we have some full basement walkout lots here, and some slab on grade lots across here. And today we're going to show you how to easily generate some preliminary volumes. And when they get totally refined, you can get your final volumes from this too. So as I said, we're going to focus on Earthwork Processor today, and we'll show you how to generate those volumes very quickly. So let me first get this existing surface off of the background here so it doesn't distract us. Okay, so Earthwork Processor, it's right here. We have 2 portions of it. We have the calculate earthworks and the offset regions. I've created the regions, so we won't be using that today. But if you were using already generated lines and they were on top of each other, you would have to offset those, because one of the rules with AutoGrader is they can't touch. So here's what it looks like. AutoGrader, for those of you who haven't seen it before, we have our options tabs right here, which controls where all of our files get stored. Here, you can path to wherever you want. You might want to path to a network location so others can share their templates and you can pull them from there too. So our surface creation right here, AutoGrader is going to create your surfaces for you. And we'll put them in a folder for you for easy organization if you select this button right here. Otherwise, it will just create the surfaces directly in your tool space. So I'm going to select that right there, and we can set some defaults here of how things are organized and laid out. I'm going to just tell it to match the defaults here for our presentation today. So then we have our labels and reports right here. We have different options to choose from. This is going to show up in your drawing label. If you put it on there, pick whatever you want here. Cancel, and we have some other precisions we can set right here. So how do we want it reported? Cubic yards, meters, feet, whatever. And then our rounding, pretty standard AutoCAD stuff. We have the same thing here for our Excel table. So I've selected all of the same things as you can see right here. We're not using a cut factor today. That's a default, or a hand enter if you want that there. I'll show you that here in a second. And then what layer do we want it to go on? How do we want it to orientate? And those types of things right here. So if I wanted to have a default for my cut factor, if I wanted to give it a 30% shrinkage factor, I would set this to 1.3. And then do we want a default stripping depth? If we want to have that populate automatically, I'm going to leave that at 0 also. And then our table precisions, how do we want those to be? So I can use my drawing precisions, however I have those set, or I can select how I want those to go. I'm going to leave that at 2 today. So to get started, we have to hit this green button over here. This creates a new set. This one will delete just our set, and this one will delete everything, including the surfaces. And we have the option to copy our set so we don't have to go back and forth. And then we can save this out as a template. If we're doing this as a common thing, we can save that out and just pull it in and then pull it from here to make it work. This is our table to create an AutoCAD table within our drawing, and then our Excel spreadsheet. We will get to that later. So we talked about we're going to do the roads first. So let's start by giving it a name. I'm going to call it proposed roads. And we have to have our surfaces. One of the requirements is we do have to have surfaces in there. And our proposed is this CTC phase 1, which we created using AutoGrader in part 2 of the series. And then we have our existing service, so we're going to use this composite one, which we created in part 1, existing conditions, where we took a LiDAR aerial survey, and then we sent our surveyors out to shoot some areas, some things that weren't in very good detail, and then merge those into the existing surface for a composite. So with that, then we need to select our regions, as we call them. So we can do this one of two ways. We can do this by layer. We can come in here and we can select our regions. We're doing these roads. We have these two regions right here. So I can select it that way. I could use a wildcard if I wanted to right here. We see we have just the one picked right there. If I were to put a wildcard on there for selection purposes, and I hit the refresh, I'm doing everything in the ERWK prefix to my layering. So you see there's 9 others. Those are the lots that we'll get to later. So again, I'm just going to clear that out, and I'm going to select this region for the main road, and I'm going to also select for the connector road right here. So if I open this box up, this gives me a list of what I've selected for my layers. And I'm going to say OK right here, and I'm going to say OK right here, and then they're going to populate. They also need to be closed. If they weren't closed, you would get a warning right here, and it would drop one of these off the list and then force you to come back to fix those. So you notice that the naming is my layer name. We do have another option in the option right here. I've got it selected to use layer names. You could also do it by object name, however you have your drawing set up. If you have them on a good layer name that makes sense, you can do that. You could also give them a custom name right there. If I wanted to give them any sort of different naming format, I could do that there too. I'm going to leave that as they are right now. One of the other things we need is we need to have a depth for our regions. I set those when I created the lines. I'm going to jump out here and show you. But we set those when we created the lines. So one is 4 feet for our subgrade depth from the top of pavement down to our subcut. And the minor roads are 3.3 from the top of our surface to our finished surface to our subcut depth. So before I run that, I'm going to close this. I'm going to show you some of the things I was talking about. So in order for Earthwork Processor to work, it has to be closed. So we have to make sure it's closed. And then our depth comes from right here. If I change that depth to 0, that will be reflected back when I open up Earthwork Processor again. And we can give it a depth there. So I'm going to just set that to 0 right now. The other thing is I mentioned they cannot touch. Oops, I didn't want that one. They can't touch. So just to show you what I'm talking about, I'm going to take my display width off of there and show you what I'm talking about. So where these two connect on this road right here, where the main road gets subcut deeper than the adjacent roads, there are 2 separate regions for that depth, and they have to be apart. So these are 0.01 apart, and they could be anything you want, up to 8 decimal places, just so they don't touch. I use 0.1 just for display purposes. Let me give that a width again, so we can see them more easily. Okay, so now we're set. We can run these volumes from Earthwork Processor. So I'll come back up here. I'll open Earthwork Processor again. Bring it over here so you can see. So as I mentioned, I made it 0, so now it's reflective of that 0. So they could all be drawn at 0, and you could give them a depth at this point too if you want. So I'm just going to say 3.33 again to match what it was, and I could give this as many as I want, but I set my precisions to 2 places, so that's what we're seeing. So with that, we're ready to run it. So I'm just going to click run right here. And it's going to create a couple of different surfaces here to compare to, do some pasting, and get our volume surfaces right here. Now I mentioned I didn't add stripping to this. So we're getting the raw cut fill and the net are the same in this case. If I were to give this a stripping depth, what's going to happen? Right away you see it goes out of date. So something changed, so those numbers are no longer any good. So I'm going to just going to hit run again to show you what this is doing. So if I had regions that I wanted to strip versus the whole site, I would add that to it. So now I get numbers for my stripping volumes as well. And what Earthwork Processor does is it takes our cut and it subtracts off our stripping for our net. So we're assuming that your stripping is staying on site, so it wouldn't be included in any sort of hauling situation. So that's where that number comes from. Now let me set that back to 0 and just rerun it, because we're going to strip the entire phase 1 area and get a stripping surface for that too. So let me show you how that works, if that was what you wanted to do. So I'm going to call this one phase 1 stripping. And now here I don't need a proposed surface in this case, because I'm just going to take it all off of the top. So in this case, I can use the existing ground for both surfaces to get my stripping area. And so I have a boundary for my stripping area, which is just a boundary that I pulled off of my surface and then pushed it out for this whole phase 1 area to get that stripped ahead of time. So it's this boundary line right here. I'm going to pick that. Again, I get my 1, and it's telling me it's the tin boundary, and I've got a ½ a foot of depth to that. I gave it a depth ahead of time. We don't need to be concerned about this because we're just going to take it right off the top. So if I hit the run right here, it's going to go and calculate that volume. So here's my strip area volume for the entire phase 1 surface. So here, let me close this and show you what that looks like on a profile. So let's just make a quick profile for this that's reflective of our surfaces to see what our surfaces look like. So I'm just going to bring it right across these 2 roads right here and include those lots as well, so we can see those after we run that surface. So with that, I'm just going to go right to the native tools right here. I'm going to create an alignment just like you would natively. I'm going to call it surface check for my name. I don't need it attached to the site or anything like that. I certainly don't need to do that. So now that I have my alignment created, from here I can create a profile with those surfaces on there to see what that looks like. Again, all native functionality here. So I'm going to include the phase 1 surface. I'm going to include the existing ground, the composite we created, and I'm going to also, I will add the stripping in this case too, and then the subgrade for our roads. So let me just change these styles up. I have different styles for these. Put that on design. We got existing ground, that's fine. So we have our stripping style. I have a style for stripping, and then our subgrade. So I set my subgrade, say okay, it's just all native creation. I think that's all good. Let's create a profile and see how that looks. So from here we can see now we've cut through right here. We see the finished ground for the lots right here, these slab on grade lots. We see our basement lots, our full walkout basement lots here, and then we see our subcut for our main road down here. So that's where our volumes are coming from. And then here's our stripping. So we took a 1/2 foot off of the entire surface. So in this case, if you wanted to use that for your volumes minus that, you could use that stripping surface. So with that, let me show you where those get created over here. And we told it to create folders for them. So they're being created right here. So here's the stripping, and I'm calling it the phase 1 stripping. And by default, it puts the subgrade and the earthwork, the volume name out there. So if I wanted to use that stripped surface as my finished ground, I would just use this as a substitute for that. And then here's our proposed road surfaces right here where our subgrade, our line there, is coming from. And then our volumes, where our volumes get generated. So that's how all of that works and where our numbers are coming from. So now we can go ahead and we can get some volumes for these lots, and just these lots. So none of this other green space here. We're just going to generate volumes for these lots. So we got some extreme cuts in some of these cases. So we're going to see those numbers here. So all we need to do is we need to open Earthwork Processor back up. Get it and bring it back over here. So let's do one for our lots. So let's just make another set right here. And let's do it for, let's call it proposed lots. So we have our proposed lots right here. Again, I'm going to use the previously created phase 1 surface for that and the composite surface. And now I'm going to go through the same steps right here to grab those. So this whole, the lot boundaries are going to be included in our volume reports. So by that one, it got 3. So I don't have to go back and pick again. We talked about the wild card. If I give it the wild card there and hit my refresh button here, now we see we have 7 total. So if I say okay right here, you see they get populated. So we've got 4 full basement walkout areas and 3 slab on grade areas to go. They all have depth to them. Our full basement walkouts, when we preliminarily graded it for the back of these, we went down 7.5 feet. I'm going to push it down another 1/2 foot for our rough grading back there for these full basement walkouts. And then these 150 ones are the front of the walkout areas. And again, we're not going to include the stripping. If I wanted to use that here, I could as my stripping. If I already had that off and I don't want to include those volumes, I could grab it right here. In fact, let's do that. So we're only going to get volumes from where the new surface is with the stripping off of there. So that won't be included. So now if I tell it to run right here, It's going to find all of those regions. It's going to calculate the depths and create our volumes. So we've got some fill areas and some cut areas right here. So those are our volumes. Now we can see what those look like on our profile. So let me close that. And I'll show you again how I created these regions. I left this area in here for a little bit of slop in there, because we know we're not going to grade straight up and down, nor should we, and our volumes won't be affected by that. So this is our frontal areas right here with our driveways, and then our basement areas. This is the one I put down at 8 feet for this one, this one, this one, and then we have all our slab on grades. So let's add those to the profile and see what they look like. Again, the same standard Civil 3D method to do it. So we've got our lots right here. I'm going to just put the subgrade lot in there. If you did the earthwork one, it all starts at 0, so you would see those way down, which we don't want that. And I'm just going to call these, I think I'll call them subgrade again. In fact, let's see what this one looks like. Let's put it standard. Hopefully that's a different color to see what that looks like, and then see what that does in our preview. So here we can see where these are coming from. It's creating our depths from our finished ground right here. So 1.5 feet below at the slab on grades, and then it's doing the calculations down and then finding its way back out and picking up the existing, or the proposed surface for our top. So the volumes are coming from this area and this area. So here's huge cut areas right here in this cross section, and some fill areas for right here. So I think that's really all I had to show you today, to show you how we can get some, oh wait, nope, I take that back. Let's pump that out. I said we were going to kick that out to an Excel so we can see what that report looks like. Let me open that back up and bring it over here. I could create the table too in the drawing. Let's do both. So I have to, in fact, highlight all of these. And then I can create my table. So it's asking me where do I want it to go. I'm just going to pick right there arbitrarily. And there's our table. That's being controlled by your table style from your annotate tab up here. This happens to be the standard style. And we can select that too in our options. I'm just using the standard. But this is what we're getting in the table. Now, if we wanted to change some of those, we would just select different things in our selection, in our options like we talked about. So let's open Earthwork Processors back up and then create an Excel out of that. Show you guys how that happens. So again, as I said, that's coming from our labels and reports. We got our text style right there for our table style right there. It's coming from, and we're going to get this to Excel. So I'm going to say OK out of this. And I have to highlight which ones. If I want to do these one at a time, I could. I'm going to do all 3 of these again for our Excel table. Oh, and if you wanted to reorganize these, let's do that. In fact, I'm going to push the stripping one down. So we'll have our roads, then our lots, and then our stripping. Whatever your workflow is, however you want those to look. And they can be edited anytime in our Excel table because it's a standard Excel table. It's nothing magical. with proprietary stuff. So it was just asking me if I wanted to open it there, which I do. And here's our report. Now again, this is a standard Excel table, so we can do whatever we want to it to save it out and share it, OLE, build any formulas we might want in here for checking or other reports we might want to do. So very versatile, as with all the rest of our tools. So now with that, that's all I had to show you today. Let's jump out to PowerPoint and finish this up. So as I mentioned, it's part of a CTC CIM Project Suite of tools. We also have our CIM Manager Suite of tools. We're currently at version 24.5. When Autodesk releases 25, we will bump our version up to 25.0. So if you don't have our tools and you would like them, you can contact your local reseller, or if they don't offer it, you can contact us here at ctcsoftware.com, and we'd be glad to help you out in that regard. And as always, if you have any ideas or need any help, contact us here at support. We encourage you to submit any ideas, wish lists that you might have for our tools, as our tools are built for you, the user, and we like to improve your workflow. So with that, thank you for joining us today. I appreciate your time.